My name is Srushti and I will give the introduction. Now, what is LDR? Light dependent resistors LDR, also known as photoresistors or photocells, are electronic components that exhibit a relationship between light and electrical resistance. The fundamental principle of LDR lies in their ability to alter their resistance in response to changes in incident light intensity. The function of LDR is to change the electrical resistance in response to intensity of light, which means when exposed to more light, the resistance of LDR decreases, which allows more current to flow through it. Conversely, when there is less light, the resistance of LDR increases, restricting the flow of current. This relationship between light intensity and resistance in inverse can be mathematically expressed as R is directly proportional to 1 by L, where R is the resistance of LDR and L is the intensity of light. These unique characteristics makes them valuable in diverse fields ranging from automatic lighting systems to camera exposure control.
So hello everyone, I am Hariharan and I will be explaining the circuit that we have today to do the LDR experiment. So here we have the Arduino Uno board, the most important LDR resistor, an LED which you will be using to indicate whether the light around us is less than some specified value, and we also have some jumper wires to make the circuit complete. So here it goes. Here we have the 5 voltage input to the LDR resistor and it's connected to another resistor that we have and it's grounded via this blue wire. In order to get the analog inputs from the LDR, we will be using a jumper wire and we'll be connecting it to the LDR over here and to the A5 analog port of the Arduino Uno board, through which we will be getting the analog inputs and we'll be showing it on the serial monitor that we have on the laptop. So here we have the Arduino IDE in which we'll be writing the code over here. First we have int is equal to int light. We'll be declaring light as an int variable. And the setup we have pin mode 10 output, which we'll be using to light up the LED which we have over here. To indicate, like I said, like we'll be using it as an indicator. And here we have the serial begin 9600. And here the serial means that like we'll be calling the serial monitor to show up on our laptop. And 9600 means the baud rate which we'll be using. Baud rate refers to the bits per second, in which we'll be getting the signals. And in the loop, we have the analog read FI light. I mean, we'll be assigning the analog read, I mean, the input we get to the light variable. And here's the part we will be mentioning that if light is less than 150, we'll be lighting up the LED which we have here over here as an indicator. If it else, it will be remained as shut. The thing is like when the surroundings light value gets less than 150, we'll be lighting up this indicator LED. Also, the most important thing is like we will be printing the value which we will be getting via the LDR, via the command serial print in light at a delay of 1 second. At each second, we will be getting the value and we'll be printing it on the serial monitor.
Hi everyone, this is Snehal and today I'll be discussing about the results of the LDR experiment. As you can see here, we have an LDR and the LED, and here we have the serial monitor which is plotting the intensities of the LDR. Now when I try to block the light from the LDR, we can see an instant glow in the LED, and we can also see that the values have dropped on the serial monitor. And now as soon as I lift my hand off, we can see that the values are back to being high. Now we can see the same phenomena on the serial plotter. So here we find an increase in the peak value of the intensity, and as I block the light from the resistor, we can see an instant drop. And now as soon as I lift my hand from the LDR, there is a peak appearing again. This shows that the resistance offered by an LDR is inversely proportional to the light received on it. And concluding this, we find many practical applications of the LDR, like using LDRs in streetlights where we can have an efficient use of electricity. Thank you.